All right, hello everyone. This is 6.2, transforming and combining random variables. So our learning targets are to describe the effects of adding or subtracting a constant or multiplying and dividing a constant on the probability distribution of a random variable, calculate the mean and standard deviation of the sum of differences of random variables, and find probabilities involving the sum and difference of normal random variables. So in chapter 2, we studied the effects of linear transformations on the shape, center, and variability of a distribution of data. So this should be a little bit of a review, but remember that adding or subtracting a constant, um, it behaves the same way to the center, right? To the mean gets added and subtracted, all right? Adding and subtracting does not change the variability, and it doesn't change the shape of the distribution either. This is because adding or subtracting, if you do it to every data point, it just shifts the data up or down. It doesn't change how it looks or how spread out it is. It just moves it up or down, which moves the center, and that is all. On the other hand, multiplying or dividing each observation or each data point by a constant b, it multiplies or divides the center. So the center always behaves exactly how you expect it. It will now multiply or divide the spread of the data, but it does not change the shape. The shape will always remain the same when you are adding or subtracting a number, or multiplying or dividing by a number. All right. Center always behaves the same way, and then the spread will only be multiplied or divided. It will not be added or subtracted. So Pete's Jeep Tour offers a popular day trip in the touristy area. Let C equal the total amount of money that Pete collects on a randomly selected trip. We saw this distribution couple in the last video. So here it is. All right, so 300, 450, 600, 750, 900, and their probabilities. So it cost Pete $100 to buy permits, gas, and a ferry pass for each day trip. So let V equal the amount of profit that Pete collected on the randomly selected trip. So before it was the money that he made or money he collected, and now it's the profit. So now each one of those data points has been subtracted by 100, all right, because each trip costs $100. All right, so we now go 200, 350, 500, 650, 800, and we can see, hey, my mean did get moved, right? My mean was about between 450 and 600. Now it's between 350, 500. So the mean, okay, which was exactly 462.5, is now 100 less, or is 100 less than what it was before at 552.50 cents. However, the variability will stay the same. All right, variability stays the same, and then the shape of the distribution does not change ever. It never changes. All right. I'm quickly doing some calculations to possibly show you in this video how to do that. Okay, so I didn't show you this in the last video, so I'm just going to pop out here real quick and show you. So if you wanted to put this data in to get your calculator to do it really quickly for you, you can go to Stat Edit, right, and we're going to go just into L1 and L2. All right, clear, clear. Now I'm going to type in my data. I'm going to do it for the V1. All right, so the profit. So I have 200, 350, 500. Oops, sorry. 500, 650, and 800. And 0.15, 0.25, 0.35, 0.2, 0.05. So I have the counts in one, or the variable in one, and then the probabilities in the other. I'm now going to go to stat calc, and I'm going to do one var stat. If you have the old calculator, you do L1, comma L2. If you have a new calculator where it asks for frequencies, the frequencies is where you put L2 in. It's no longer frequencies, it's probabilities, but it'll behave the same way. And then we get out, hey, this is 462.5, and my sigma is 163.46. All right. So just that way to see it, one var stat, L1, comma L2. So just as a recap, adding or subtracting a number to each of the random variables, it adds or subtracts to the mean, does not change the variability, does not change the shape of the distribution. Right. And this is a nice note, adding or subtracting changes the quantitative variable, right? Like we were just talking about, like male heights, for example, in chapter 2. It does the same thing that it does to a probability distribution for a random variable. All right. So in a large introductory statistics class, the score X of a randomly selected student on a test worth 50 points can be modeled by a normal distribution with a mean of 35 and a standard deviation of 5. Due to a difficult question on the test, the professor decides to add 5 points to each student's score. Let Y be the scaled test score of the randomly selected student. Describe the shape, center, and variability of the probability distribution. So we're adding 5 to everybody's score because we're now doing distribution of Y. So the shape stays approximately normal because it was before a normal distribution. The mean now gets added by 5. So the mean was 35, now gets added by 5. It's 40. And the variability does not change. It was a standard deviation of 5. It remains 5. All right. The effects of multiplying or dividing a number. All right, it multiplies or divides the center. It does multiply or divide the variability, and it does not change the distribution. Again, this behaves the same way for probability distributions as it does for a regular quantitative data distribution. So here is an example of effect of multiplying or dividing by a constant. El Dorado Community College considers a student to be full-time if he or she is taking 12 to 18 units. The number of units X that a randomly selected El Dorado Community College full-time student is taking in the fall semester has the following distribution. At right is the histogram of the probability distribution. The mean is 14.65 and the standard deviation is 2.056 at El Dorado Community College. The tuition for full-time students is $50 per unit. That is, if tuition charged for a randomly selected full-time student is 50 times X. So these are the number of units. Now we're trying to figure out how much that cost is. That T is the cost of tuition. So I'm going to multiply each of them by 50. The shape does not change, right? The shape stays the same. The mean does get multiplied by 50. So I do 50 times the previous mean to be $732.50. And then the variability does also change. It also does get multiplied by 50, right? This is called a linear transformation. So a linear transformation on a random variable is the form y equals a plus bx. All right, all it is that, hey, I'll go back a slide. A is like adding a number, right? So if it was just a plus x, that's just adding a number, what would happen? B is just multiplying by a number. So it's a way to put it all together. The probability distribution of y has the same shape as the probability distribution of x before, because multiplying and adding does not change the shape. The mean now, however, the mean gets multiplied by b and added by a. It does both. All right, so it'll get multiplied and then added, and that's how I get my new mean. My standard deviation, however, though, just gets multiplied by the b. So the a doesn't affect it. They put the absolute value signs there because a or b could be negative. All right. However, we know that standard deviation has to be a positive number. All right. It has to be a positive number because it's the distance. So you multiply by the absolute value of b. So that's one way to kind of put it nicely together. It's basically saying, hey, A doesn't affect this at all here. And note that these do apply to both discrete and continuous random variables. So that was all about linear transformations and adding or subtracting constants and multiplying or dividing constants to a random variable. Now we are going to be combining random variables. So we're going to take two random variables and put them together. So let X equal the number of passengers on a randomly selected trip at Pete's Jeep Tour. So that's the distribution we've seen before. Pete's sister, Erin, runs Jeep tours in another part of the country. Here is her distribution. All right. So they're asking, what is the sum, which is X plus Y, of the number of passengers Pete and Erin will have on their tours on a randomly selected day? And what is the difference in the number of passengers Pete and Erin have on a randomly selected day? So those are two different combinations of random variables we could find. So for a random variable, the means behave the same way, all right? So the sum, right, that is mean of X plus Y, S is equal to X plus Y. That is just gonna be mean of X plus mean of Y. So the mean of the sum of two random variables is equal to the sum of their means. What you'd expect to happen, both their means added together. For the difference, same idea here. The difference is just a difference. You subtract the two means, all right? The means usually play nice, we say. It behaves how you would expect it to behave or does what you'd expect it to do. Right? So Pete charges $150 per passenger and Erin charges $175 per passenger for a Jeep tour. Let C equal the amount of money that Pete collects and E equal the amount of money that Erin collects on a randomly selected day. From our earlier work, we knew that mean of C is 562, and it's easy to show that mean of E is 540. You could just go back to the data and calculate it. Let's do that real quick for some practice. Well, actually, how much does she charge? Erin charges 175, so you'd have to multiply these all by 175. Let's see if I can do some math. So stat, edit. So it's not going to be 2, it's going to be 2 times 175, which is 350. And it'd be 525. At 875. And then I'd get, hey, 0.3, 0.4, 0.2, and 0.1. I'm gonna go to stat, calc, 1 var stat. I gotta do, hey, L1, comma, L2. Enter, and there we go. There's our mean. Let's see if we got it here. So Erin's mean should be 542.5, which it is, and we even got their standard deviation. So we're good to go. So a little more practice right there. So if Pete charges $150 per person, oh, we saw this, we calculate and interpret the mean and standard deviation, or sorry, the mean of S. So S is just a combination of the two by adding, so the means are just going to be added. 562.5 plus 542.5 to be $1,105. So Pete and Erin expect to collect a total of $1,105 per day on average over many, many randomly selected days. So S, here's their two distributions. S is the total number of passengers who go on Pete and Erin's tours on a randomly selected day. If knowing the value of X does not help us predict the value of Y, then X and Y are independent random variables. We've seen that in the last chapter, right? So it's reasonable to treat the random variables X, the number of passengers on Pete's trip, and Y, the number of passengers on Erin's trip on a randomly chosen day, as independent, because the siblings operate these trips in different parts of the country. All right, they're not very close to each other, so you wouldn't expect them to kind of be competing for customers or anything like that. So you'd expect them to be independent. All right, and therefore independent events is just P of A times P of B. So there are two ways to get a total of 5 passengers on a randomly selected day. So you could have x equals 3 and y equals 2, or you could have x equals 2, y equals 3. All right. Those are the only two ways to get your 5 passengers. So the probabilities of those, right? 2 and 3, right? Well, that'd just be the probability of Pete getting 2 and Aaron getting 3 is here. Probability of Pete getting 3 and Aaron getting 2 is here. You add them up together, that's a probability of getting 5. All right. So they found the probabilities. You may ask, like, why did we just do this whole problem? In order to find the probability distribution of S, which is the number of people combined, right? The events are very easy, right? They both have less or the fewest is 2 for each, so 2 and 2 is 4, and 5 and 6 and 7 and 8 and 9 and 10 and 11. Those are easy to find, but the probabilities, you do have to add up all the different ways that they may occur. And that's why they're both independent and then therefore not mutually exclusive. That's why you don't subtract anything away here. Okay. So we have Pete's distribution, Aaron's distribution. You add them together, right? So in order to get 4, it would only be 2 and 2. So 0.15 times 0.3 got me here. 5 could either be 2 and 3 or 3 and 2. 6 could be 2 and 4 or 4 and 2 or 3 and 3 also works. So that's how they got 6 and so forth along the way. They've now done the probability. They found all the probabilities, and then therefore they have taken the standard deviation as well. So the question of how do their variances relate? Remember, variance is the standard deviation squared. How do they relate? Well, if you did x plus y, you'd get your sigma out. All right. However, if you added x and y, just the regular standard deviation of x and the standard deviation of y, you are not going to get the correct standard deviation out. All right, it's going to be too big. So if you are adding and subtracting random variables, all right, remember the means behave how you expect them. You can just add or subtract them. They behave the exact same way. To find the variance, or sorry, to find the measure of spread, you actually have to add the variances together and then take the square root. All right, you have to add the variances together and then take the square root to get the standard deviation. So when we take two independent random variables, that's another important thing. They're independent random variables. We will almost always give you independent random variables, so you have to do this. Their variances add, their standard deviations do not. You have to add the variances and then go back and take the standard deviation or the square root if you want the standard deviation. So here we go. Now we're going to do subtraction. All right. And note, this is not a typo. What do you notice happened? See if you can pick it up. What just happened when we subtracted x minus y to get the new standard deviation of t? Right, if you don't see it, it's the exact same thing as before. All right. When you added them, you added their variances together and then took the square root. When you subtract the random variables, you actually add their variances still and then take the square root. It behaves the same way if you add or subtract for standard deviation. All right. So if you subtract random variables, you still add their variances and then take the square root. So when we subtract two independent random variables, their variances add. Right? Just another caution put out there. So Pete charges $150 per passenger and Aaron charges $175 per passenger for the Jeep tour. Let X equal the amount of money that Pete collects and E equal the amount of money that Aaron collects on a randomly selected day. From our earlier work, it is easy to show that the standard deviation of the cost, of Pete, and the standard deviation of Aaron is there respectively. You may assume that these two randomly variables are independent. You have to do that in order to do this. And then you define D as C minus E. Earlier, we found that the difference in the mean was $20. Calculate and interpret the standard deviation. So I have to do the variances. So I have to multiply this by 2, I have to square both of these values and then add their differences and take the square root. So let's go ahead, let's see about this. All right, got my calculator up now. So I'm going to take, so C minus D, so I'm going to do 163.46 squared plus, I know it says subtract, right? I know it says subtraction, but we are always going to add their variances. Plus 165.03 squared. Press enter, second square root, second answer. So what we get, 232.28. Sure enough, we get it. So the difference between Pete and Aaron in the amount collected on a randomly selected day typically varies by about $232.28 from the mean difference of 20. So don't forget about that context there. All right. So far, we've concentrated on developing rules for means and variances of random variables. What happens if we combine two independent normal random variables? All right. So what's going to happen? Any sum or difference of independent normal random variables is also a normal distribution. So if it was normal and you add two normal distributions together, it will remain normal. The mean and standard deviation of the resulting normal distribution can be found using the appropriate rules for means and standard deviations that we just discussed. All right, so it's the same idea. It is two random variables that you're combining, behave the same way. It just means that the shape are the same. That also means that if you don't know the shape, you won't know what the final shape is. All right, you can only know it if they are normal, they will remain normal. If both of them are normal, they will remain normal. All right. So here, the diameter C of the top of a randomly selected large drink cup at a fast food restaurant follows a normal distribution with a mean of 3.96 inches and a standard deviation of 0.01 inch. The diameter L of a randomly selected large lid at the restaurant follows a normal distribution with the mean 3.98 inches and standard deviation of 0.02. Assuming that L and C are independent random variables, let the random variable D equal L minus D. Can be the difference between the lid's diameter and the cup's diameter. Right? So describe the distribution of D. So the shape is going to be the same. It's going to be normal. Both of these are normal. Right? C is normal. L is normal. So the shape is going to be normal. And we now have to find their means. Their means behave the same way. We're going to subtract. So we're just going to subtract L minus C for the means. So it's going to be 3.98 minus 3.96. So that is my, let's see, this go, okay. That is my shape was normal. That is my center right there, or my mean. And then to find the variability, remember we do multiply, all right? Or we add their variances. So 0.02 squared plus 0.01 squared. What's that? Take the square root. 0.0224 inches. So same situation, we just did A. So B now, for a lid to fit on a cup, the value L has to be bigger than the value of C, but not more than by 0.06 inches. Find the probability that a randomly selected lid will fit on a randomly selected cup. So you want L to be bigger than C, but it can't be bigger than 0.06. So what are we going to do? We're going to use that combined data that we had. We're going to use our new mean of 0.02 and our standard deviation of 0.022. All right, and now if it has to be positive, right? I need L to be bigger than C, so L minus C has to be bigger than 0. So that's going to be my one cutoff, and it can't be bigger than 0.06. So 0.06 is my upper cutoff. So I'm going to go from 0 to 0.06. If it's less than 0, right, now the cup's bigger than the lid, so that doesn't work. And if it's bigger than 0.06, the lid's too big, it won't fit on. So I'm going to show you how to do it. I'm going to do stat calc. Sorry, no, I'm going to go second vars normal CDF. All right, I'm going to use my bound, so 0, comma, 0.06, comma, the mean, which is 0.02, comma, and our standard deviation is 0.0224. All right, and I press enter, and I get 0.776 or 777 really. My rounding might be slightly different, just depending on if you use 0.0224 or something slightly different. All right, you could also change these into z-scores if you wanted to. If you have your calculator, there's not really a need to, but you could if you wanted to. Z-scores are nice to compare this distribution with another distribution, but we're not doing that here, so a z-score really is not necessary. So here's it if you did it in the calculator. Lower, remember you can't just write this out or the answer, you have to write this whole statement out. Normal CDF, parentheses lower equals 0, upper equals 0.06, mean is 0.02, standard deviation is 0.0224. Get out my standard deviation, my probability. So the probability that this lid fits on the cup, or random selected lid fits on the random selected cup, is 0.7770. So there's about a 77.7% chance that a randomly selected lid will fit on a randomly selected cup. Right? And that's all we have for today. So we wrapped up adding, subtracting, multiplying, and dividing by a constant to a random variable, and then adding and subtracting two random variables, and seeing how that affects the mean, standard deviation, and normal distributions. And then we used it to calculate our normal distribution. So that is all. Have a good one.